and then multiply it. Okay, and we will focus only in the video. Only discussion will be carried out for coupling constant. Okay, so it is very important topic of NMR spectrum. Okay, and it identifies the pairs of nuclei that are chemically bonded to each other. Okay, so suppose that I have mentioned this structure, and the coupling constant will be for this proton, and the splitting pattern will be the doublet. If here any other electronegative atoms will be joined. Okay, so for this proton, doublet will be appeared. Okay, and in doublet you can determine the coupling constant. Okay, so multiplicity identifies the number of protons that are chemically bonded to the other nuclei. Okay, so in the NMR spectrum you can see different types of splitting pattern like triplet, quartet, pentate, sextet, nonate, like that. Okay, and multiplets. Okay, but in singlet and multiplets you cannot identify the coupling constant. Means only in doublet, triplet, quartet, double doublets, etc. Okay, in this you can determine the coupling constant. Okay, so the and the coupling constant, the application of coupling constant is to identify the coupling partners and provides the information on dihedral angles, hydrogen bonds, and number of intervening bonds and type of coupled nuclei. Okay, so it is the application of coupling constant. Okay, so next you can see here different types of splitting pattern I have mentioned, and you can easily determine which splitting pattern will be occur in different types of organic compounds. Okay, so for this, because there is one hydrogen near there is no hydrogen, so only singlet will be appeared by applying the n plus 1 rule. Okay, so in this near one hydrogen is present, so for this proton doublet will be appeared. Okay, and in doublet, in singlet you cannot identify the coupling constant. Okay, because it is the distance between two splitting pattern. Okay, so it is the splitting pattern 1 and the other is 1. Okay, so in between, the distance between this peak and this peak is called coupling constant. Okay, so this area majorly uh, mentions as a J value or coupling constant. Okay, so coupling constant from doublet you can identify. Okay, so in singlet, this is very major point, that in singlet and multiplet you cannot identify the coupling constant. Okay, so for taking these theoretical point will be applied here in the form of experimental. So this is the spectrum of this compound. Okay, so in these two 12 and 13 you can identify the splitting pattern, and for this doublet will be appeared. Okay, so in this you can see different types of doublet appeared here. So if you want to calculate the J value, then first of all you will subtract the higher to lower values. Okay, so 7.9192, it is the higher value, subtract 7.91, so it will occur 0.1. Okay, so and after subtracting you can multiply the NMR, means which megahertz NMR is running. Suppose that your NMR running as 500 megahertz, so you can multiply from that value, so 10 will be your J value. Okay, so for this 10 will be J value, and for this 10 will be J value. Okay, so it is the method to calculate the coupling constant. Okay, so next one we will see here in triplet. So in triplet, the major point is that in majorly in, if you are going to write down, suppose that you are going to report this compound in the research article. Okay, so which value of doublet, means which NMR value you will mention. Okay, so it is the question mark. So first of all you put the cursor from this, so this distance. Okay, so this will be the value of your proton NMR. Okay, so 7.91, this is the 7.92. Okay, so put the cursor from this one, and you can identify, you can see the exact NMR value which will be mentioned in the research article. Okay, so here by taking the compound in which triplet will be appeared. Okay, so this is the J value for this is the splitting, this is the splitting. So distance between these two peaks is called J value, and it is similar as similar like that one. Okay, so this is the J value which will be the 6.1, and it is also similar for this area. Okay, so and if you are going to which NMR value, you will mention the paper 5.76. Put the cursor from this one, and your software will able to show the NMR value. Okay, so 5.76 ppm is the exact NMR value. Okay, so in doublet, put the cursor from here. 3.96 ppm is your NMR value. Okay, so in this you can also calculate the J value. Okay, so if you see this one, this is the multiplet, this is the quartet, this is the quartet. So this area is called J value. You can calculate from that. Okay, so this I have mentioned different organic structure in which already the J value has been calculated. Okay, so in between range you can remind that these will be appear in this range. Okay, so this is similar, and coupling constant here, this is the doublet, this is the exact doublet. Okay, sharp doublet you can see. Okay, so you can calculate easily J value. Okay, so 7.94 and 7.945, so it is the higher value, so subtract lower from higher value, and you can find the 0.01 and multiply the megahertz in which NMR your NMR instrument is running. Okay, so you can find the J value. So it is also I have mentioned different types of organic compounds in which a fixed J value will be occur in between range. Okay. So by this method you can also identify the J value. Okay. So it is the topic I have covered. Okay, how you can identify the J value. Okay, so it is very important topic in NMR spectroscopy. So please, if you have any queries regarding this topic, then please write down the your queries in the comment box. We will give your answer. Okay, so thank you for watching this video, and we will meet later. Okay.